Bismillahirrahmanirrahim. Assalamu alaikum. This is our lecture 2, and we are going to go through the signal and systems in this lecture. What are the signals? Signals are actually the description how one parameter varies with another variable. System is a process that creates signals. For example, we have a system here, and x of n is the input, and it is giving us y of n. It is generating the signal which is y of n. Why we use systems? We use systems to achieve the desired objectives, our desired requirements, and the signals can be of two types. They can be continuous or discrete. Here are some examples of the systems: the flip system, shift system, and the index scaling system. In the flip system, when this is the system equation, and when we apply signal, when we give input to this signal, it will flip the signal. It will just flip the signal. In the second case, the shift system, this is the system equation, and when we give some signal to this system, it will shift our signal to the right or left. If there is plus sign here, then and plus 2, it will shift our signal 2 times on the left side, and if there is -1, it will shift our signal 1 time on the right side. It is the delayed signal. It gives us a delayed signal. In the third, we actually scale our indexes. If some constant is multiplying, for example here 2 is multiplying with n, then it will compress or squeezes our signal 2 times. And this is the opposite of the this previous signal, previous system. In it 2 is dividing with the n, so it will expand our signal 2 times. This is the expanding system, and it was squeezing or compressing a system. For example, if we have some question in which we have to apply all the 3 techniques: flip, shift system, and the index scaling, then we'll give priority to the flip, then shift, and to the scale. First we'll flip our signal, then we'll apply shift system, and at the last we'll apply the scale system, and this will be our, for example, if this is the input, then it will be our desired output at the end. You have noticed that if we apply some technique, for example, if we apply index scaling, this squeezing signal, it squeezes this signal into this signal, and when we apply the opposite operation on it doesn't give us this original signal. It gives us this signal. So to extract the original signal from the expanded or compressed signal, how we can extract our original signal? For that, we'll go through the 3 techniques, which are the 0 order hold, first order hold, and the second order hold. In the first order hold, we consider one sample, and what we actually do we actually draw the replicas of the spikes at their exceeding values, where at their exceeding points where the values are zeros. For example, here the value is 0, here the value is 0. We'll draw the replicas at these points. After drawing the replicas, we join these points, and then we calculate the error. But this method is not very good. It do not reduces our error, so we'll leave that, and we'll go to the next. The next one is the first order hold. In it we consider 2 samples. In the previous we were considering 1 sample, here we are considering 2 samples. We are doing the same thing, but here we are directly, first step will be joining the spikes, then we'll join the zeros with the slope. This is actually the slope. Then we'll calculate the slopes at those points where the values were zeros by using this formula and by using the equation of line. In the third method, which is the second order hold, we are computing three samples. uh, what is slope? Slope is actually the derivative, and derivative tells us the similarity between two things or two functions. On taking derivative, the curves will be more clear. Here we have these pointed edges. By taking the derivative in the third method, these curves will be more clear in this form, and it will be look like an analog waveform or something like that. And we can also improve our system by doing this by drawing the sync function at each spike. Sync function is equals to a sine of x over x, and its graphical structure is like this. And if we draw the sync function at our each spike, it will give us some good results. So these were the three techniques to extract our original signal. Okay, what is impulse function? Impulse function is something like this, which only gives us value at 0. It's mathematically it gives us 1 at t equals 0, otherwise it is 0. It is only single spike. So we can synthesize our any signal by using the impulse signal. For example, if this is our desired signal, we have to synthesize this. Then what we will do, we'll take an impulse function, we'll shift it here at ss at n-1, and then we'll shift and flip it here. We'll flip it and shift it this point, and then by adding the both b and c and a, actually here is also an impulse, we'll get our desired signal. As we have synthesized our signal by using a single impulse function, we can also decompose a signal into the impulses. Impulse function is a decomposer. Step function is also a decomposer. In the same way, even and odd, there are two more decomposers, which are the even and odd decomposers. Their formulas are given here, which is this and this. And that's all for the lecture number 2.